Welcome to Mineral Projects Intel, where we dig deeper into the world of mineral projects, where we unpack the complex world of mineral projects investment, and where we make sense of the science, strategy, and sometimes the jargon behind it all. If you've been wondering how AI is transforming mining and changing the future of mineral resources, you're in the right place. For most people, mineral resource estimation sounds like something fixed, mathematical, and maybe even boring. Drill holes go in, numbers come out, and a mineral resource gets declared. But what most people don't realize is that we are right in the middle of one of the biggest shifts this discipline has ever seen, and it's being driven by artificial intelligence. AI is not replacing geologists, and it's not magically creating mineral resources where none exist. What it is doing is changing how we see uncertainty, how we work with data, and how we make decisions long before a mine is ever built. To understand why this matters, we first need to understand what mineral resource estimation really is. At its core, mineral resource estimation is a problem of incomplete information. We are trying to describe something that exists underground based on a very small number of samples, spaced far apart, and influenced by complex geology. Every estimate is therefore a model, not a fact, and every model carries uncertainty. Traditionally, geologists have relied on statistics, geostatistics, experience, and judgment to manage that uncertainty. Variograms, search ellipses, kriging, domaining, all powerful tools, but also heavily dependent on assumptions. And this is where AI starts to change the game. One of the first major impacts of AI is in data preparation and validation. Anyone who has worked with historical drilling data knows how messy it can be. Missing values, inconsistent units, duplicated samples, transcription errors, mixed coordinate systems. Traditionally, cleaning this data is slow, manual, and prone to human bias, especially when deadlines and budgets are tight. AI driven data auditing tools can now scan entire databases in minutes, flagging anomalies that would take a human weeks to find, outliers, impossible grades, spatial inconsistencies, duplicated intervals. These systems don't get tired and they don't assume the data is correct just because it's old or archived. That alone is quietly improving the reliability of estimates before modeling even begins. The second major shift is in geological domaining. Domaining has always been one of the most subjective steps in mineral resource estimation. Where do you draw the boundary? How continuous is the mineralization? Are you over-smoothing or over-complicating the geology? Two competent geologists can produce very different domains from the same data. AI doesn't remove judgment, but it adds another lens. Machine learning algorithms can analyze multivariate relationships, grade, lithology, alteration, structure, geochemistry, and identify patterns that are not immediately obvious to the human eye. These tools can suggest domain boundaries, highlight transitional zones, and even flag areas where the geology is behaving inconsistently with the current interpretation. Importantly, AI doesn't say, this is the answer. It says, this is where the data suggests something different might be happening, and that is incredibly powerful when used correctly. Another area where AI is making a real impact is grade estimation itself. Traditional estimation methods like kriging are elegant and mathematically robust, but they are built on assumptions about stationarity, linearity, and spatial continuity. Real geology often refuses to behave that neatly. Machine learning models, such as random forests, neural networks, and hybrid geostatistical approaches, can handle nonlinear relationships much better. These models can integrate more variables simultaneously, learn from complex interactions, and adapt as new data is added. In certain geological settings, especially structurally complex or highly variable deposits, AI assisted estimation can outperform traditional methods in terms of local accuracy and reconciliation. That said, and this is critical, AI does not eliminate the need for geological reasoning. A model can be statistically impressive and geologically wrong at the same time. The best results come when AI is used alongside geostatistics, not as a replacement. One of the most important and underappreciated contributions of AI is in uncertainty analysis. Investors often see a single number, tons and grade. But behind that number lies a wide range of possible outcomes. AI is exceptionally good at running multiple scenarios, stress testing assumptions, and quantifying uncertainty in ways that were previously too time consuming to do properly. Instead of asking, what is the mineral resource model, we can now ask, what is the range of possible mineral resource models and how likely is each outcome? That shift alone changes how projects should be valued, financed, and developed. AI is also transforming mineral resource classification. Measured, indicated, and inferred categories are not just about drill spacing, they're about confidence. AI can integrate spatial data, grade variability, geological complexity, and data quality metrics to provide a more defensible, transparent basis for classification. This helps competent persons explain why confidence varies across a deposit, not just where it varies. Another major advantage is speed and iteration. In the past, updating a mineral resource model could take weeks or months. Today, AI assisted workflows allow rapid re-estimation as new drilling comes in. This means exploration programs can adapt in near real time, focusing drilling where it adds the most value and reduces the most uncertainty. This has massive implications for capital efficiency, especially for junior companies with limited budgets. Now, let's be clear about what AI cannot do. AI cannot replace sampling quality. It cannot fix poor drilling, bad QA/QC, or flawed logging. It cannot make up for a lack of geological understanding. And it absolutely cannot remove risk. It can only help us understand it better. There is also a real danger in treating AI outputs as truth rather than tools. Blind faith in algorithms is just as dangerous as blind faith in historical data. AI models are only as good as the data and assumptions behind them. The future of mineral resource estimation is not AI versus geologists. It's AI enabled geologists, professionals who understand both the geology and the technology, who can challenge models rather than be intimidated by them. In practical terms, this means the role of the mineral resource geologist is evolving. Less time spent manually cleaning data and running repetitive models, and more time spent on interpretation, risk assessment, and strategic decision making. And that matters because the world needs more minerals, not just more estimates, but better ones. Estimates that are transparent about uncertainty, robust under scrutiny, and honest about risk. AI is not making mineral resource estimation easier, it's making it more rigorous. And that's a good thing for companies, for investors, and for the long term credibility of the industry. If we use it wisely, AI won't just change how we estimate mineral resources, it will change how we think about them. Mining is evolving faster now than at almost any time in its history. And whether you're an investor, an engineer, or someone curious about where the metals in your phone come from, technology is the story you need to know. If you found this interesting, like, subscribe, and share for more mining insights. Because in the world of mineral projects, knowledge isn't just power, it's value. Thanks for watching.